Okay, in this chapter 3, we're going to study organic compounds with carbon, hydrogen, and oxygen. Okay, and oxygen. And starting now, we're going to see more and more compounds related to us and closer to our biological systems and close to our biochemistry. Okay, the reason is they contain now what? Oxygen. Okay, the first two chapters when we study hydrocarbons, we don't have them. I mean, they are closely related to our daily life. We use them as fuels. We use them as industry starting materials to manufacture our daily stock supplies. But we don't have those molecules in us. Okay, one of the biggest reasons is those molecules are what? Hydrophobic, right? We talk about in chapter 1 and 2. Those hydrocarbons that are hydrophobic. Hydrophobic means what? They don't dissolve in water. There's no way they can be in our what? Biological system. They don't participate in biological because our biological system is in water environment. Okay, you have to be able to dissolve in water in order for these molecules to participate in biological functions. So we don't have those molecules in biological systems. Okay, starting from chapter 3, you're going to see more and more molecules that are related to what? To us, to biochemistry, and to medicine. Okay, the reason is oxygen. Okay, oxygen. So let's take a look. Oxygen. Okay, oxygen first. This is the chart you guys have from chapter 1. Okay, number of bonds to be expected normally as expected in organic molecules. Okay, we know carbon has 4 bonds, hydrogen has what? 1 bond. We have seen that a lot. So here shows oxygen. Okay, in organic molecules, oxygen normally has 2 bonds. Okay, 2 bonds. And the bonding of oxygen could be either one of those. 2 single bonds and what? A double bond. Both count as 2 bonds. In this chapter, we're going to study molecules containing this type of oxygen with 2 single bonds on the oxygen. In chapter 4, we're going to study molecules with what? With double bond. CO double bond, basically. Remember, oxygen is always going to bond with what? With carbon. So in chapter 4, we're going to study CO double bond. Okay, but oxygen has 2 bonds. This chapter, we're going to see molecules with 2 single bonds on the oxygen. Okay, one of the most important or commonly seen functional group with 2 single bonds on the oxygen is this guy, OH. The name of OH is called a hydroxy group, okay, or sometimes hydroxyl group. Okay, hydroxyl group. 2 bonds on the oxygen. One is with what? Hydrogen. We don't show that, but there's 1 bond there. Okay, we normally do OH is OH, but you know OH is not one thing. OH is what? Is O and H what? Single bonded together. Make sense, guys? That means what? The O has to bind with another what? C. Remember, organic molecule is always built on carbons. So the OH is bonded to what? To a carbon. That's where the single bonds are. One is with the carbon, and the one is oxygen. With hydrogen. Okay, that group we call it a hydroxyl group. Okay, hydroxyl group. Now, depends on what type of carbon the oxygen is attached to. Okay, the OH is attached to, basically. We have 2 types of organic molecules, organic compounds. When the oxygen is attached to a saturated carbon. Okay, what is a saturated carbon? sp3 carbon. Okay, aliphatic carbon, you can say that too. Okay, saturated carbon. That means this carbon is sp3. If that's the case, we call the molecule an alcohol. Okay, an alcohol. This is an alcohol. See that? The oxygen bonds to what?
Carbon.
A saturated carbon. Okay, an alcohol. If the OH binds to a benzene ring, which is not saturated carbon. You can see the carbon is one of the benzene ring carbon. We call the molecule a phenol. You guys see that in chapter 2, right? When we name phenol, name benzene derivative, this is what? Phenol. So, if we don't want to, normally if we don't show a real structure, if we want to use a generic structure formula to differentiate an alcohol versus a phenol, we can use these two. If it is alcohol, we use the group R. R stands for what? A group, any group. But the carbon normally is saturated. If you want to represent a group that is benzene or benzene derivative that bonds to the OH, we use this AR. AR stands for what? Aromatic. Okay, AR stands for aromatic. So this is the generic formula or general formula for an alcohol, ROH. Again, R is what? A group. Okay, we will use R a lot in organic chemistry. R stands for a generic group, can be any group. Can be methyl, can be ethyl, can be this whole group, it doesn't matter. AR stands for what? A benzene ring aromatic group. Good? Okay, next. Show you a few examples of alcohol. Take a look. The structural variety can be hugely different. But what's in common for these three molecules is the OH, the O, is bind to what? Saturated carbon. You guys see that? This is a saturated carbon, this is saturated carbon, this is saturated carbon. So they're all what? Alcohols. Does it make sense, guys? They're all alcohols. Okay, the first one is ethanol. The second one is menthol. The third one is cholesterol. Okay, cholesterol. They're all alcohols.
So which one is menthol?
The second one is menthol. Yeah. All right, quick question. Or I think I have to answer the key here. Take a look at this molecule. If I don't give you the key, can you classify this molecule as an alcohol or phenol? Alcohol or phenol?
Alcohol?
Alcohol or phenol?
No, it's a phenol because benzene ring, so.
Anyone? Alcohol or phenol? She says phenol. Alcohol. Which one?
Because it's like
Alcohol. Okay, it's an alcohol. The OH bonds to what? This carbon. What is this carbon? A saturated carbon. Then there's an alcohol. It has a benzene, but the O is not what? Bonded to the benzene. Does it make sense? Okay, this is an alcohol. Okay, this is an alcohol.
So it has to be directly bonded to the
Correct. You only look at what carbon? The particular carbon that is what? Directly bound with the O. Does it make sense, guys? If that carbon is sp3, saturated, it's alcohol. If that carbon bound to the O is not saturated, it's a part of the benzene ring, then it's what? Phenol. Good? Another view of alcohol, okay, another view or understanding of alcohol is you can think of alcohols are water derivatives. The reason we say that, this is water. Okay, water is oxygen binds to what?
OH.
To hydrogen, right? H2O, H and OH. But basically water is oxygen binds to hydrogen. So if I replace a hydrogen of water with R, again, what is R? A group, a carbon group. Then I get what? I get an alcohol. So you can see that this is water, this is alcohol. They're what? Basically same thing, except water has two hydrogen. Alcohol has what? Has a carbon and what? And a hydrogen on the yolk. Okay, this is another view of alcohol. They are basically water-derived molecules. Next, naming of alcohol. Okay, naming of alcohol. We'll be very quick now, because again, guys, you have studied the naming system for 2 chapters already. You know the whole system. So here, we're going to go over the steps with highlighting some modification of the system we have studied. Okay, but the steps are still the same. First step, you do what? Find the longest chain. But one thing to be careful of this, the longest chain must include the carbon to which the OH is attached to. Right? Your OH is attached to one carbon. So the longest chain, no matter what, you have to include that carbon. Or the carbon must be what? Be part of the longest chain. That's one thing to be careful of. Number two, when you name the molecule, when you name a molecule, you replace the E of the alkane with the suffix for alcohol, OL. Okay, replace the E of alkane. What does it mean? This guy, longest chain, what? 6 carbons. What's the name for alkane? Hexane. Then we replace the E of hexane with OL. So the molecule is called hexanol. Easy? Replace the E of alkane with OL, the last E with OL. Okay, that's why I told you in chapter 1 how important it is to memorize what? The first 10 names. You can use them a lot. Yes?
Is it possible for an alcohol to have a double or a triple bond?
Yes, but you won't see that in this class. Okay, for me, you won't be worried about that. Okay. They're called phenols, but you don't have to worry about those. Next step, you number the longest chain to make sure the carbon with the OH gets what? Lowest number possible. Then locate that carbon with the OH with a number. This is 3, so you put 3 in front of what? Hexanol. So the name of this molecule is simple. There's no other groups. It's an alcohol. It's called 3-hexanol. Does it make sense? You have to use that number. Tell people where is the OH attached to. The OH is attached to what? Number 3 carbon. So these are some modifications. Okay, the longest chain includes this carbon. Name this molecule by dropping the E and adding OL. And then locate what? The function group OH. Okay, function group OH. And if the molecule has groups other than the hydroxyl group, you just name it as we discussed before. Okay, so this molecule is named as 1, 2, 3, 4, 5, 6 carbons, so hexanol, 3-hexanol, and there's a methyl group here on number 2, methyl group on number 4, so 2,4-dimethylhexanol. Okay, everything else is similar. Now, when OH is attached to a cyclohexane ring, it's still an alcohol. Remember, this carbon is still what? Saturated carbon. Then the name of the alcohol, just like the name of the alkane, you add what? Cyclo in front of it. Okay, the name, this ring is cyclohexane, so the name is what? Cyclohexanol. Okay, cyclohexanol. But one thing different for cyclohexanol is the carbon with the OH automatically gets number 1 because that's the functional group. So that you don't have to tell people where is this carbon. You don't have to locate, you don't have to show the 1 in the structure. If there's other groups, you do it the numbering clockwise or counterclockwise, so the other group gets what? The lowest number. So this guy is 2-methyl-cyclohexanol. See, there's no 1 in front of it. Why? Because again, what? This number is what?
Number 1.
Automatic number 1. Everybody knows it, so you don't have to tell. There's no confusion here. Okay, because it's a ring. Okay, the ring starts with this carbon. See the difference? If there is a possible of different location of the OH, you have to tell a number. But there's no ambiguity. This carbon is definitely number 1. Then you don't have what? You don't have to tell people where is it. Does it make sense, guys? Easy? Naming alcohol? Done. Any questions? Okay, most importantly is, remember, there's a number. Unless what? A cyclohexanol. Cyclohexanol. You guys good? Naming? All right, next. A very important topic, simple but important topic, and you will see question on this in your quiz, in your test, in your final, all those. Okay, like I said, simple topic, it means you will see one question each time. Okay, whenever you take a test, you will see a question on this topic. Alcohols can be classified into 3 types. Okay, into 3 types. Based on how many groups are attached to this carbon. What is this carbon? This carbon is the carbon oxygen is attached to. Okay, we actually have a name for this carbon. We'll call this carbon alpha carbon. What is an alpha carbon? This carbon is the carbon where OH is attached to. Then based on how many groups are on this carbon in red, we classify alcohol into 3 types. If there is one group on this carbon, we call the alcohol a primary alcohol with a 1 and a circle on it. It's called a primary. If there's 2 groups on this carbon, we call it a secondary alcohol with a 2 little square on the superscript. If there are 3 groups on the carbon, we call it a tertiary alcohol. Again, R are groups. Can be any groups as long as the R is a what? Is a carbon. You get it, guys? Okay, another way to look at it. Okay, this is by definition. What is primary? What's secondary? What's tertiary? Primary is what? 1 group on this carbon. Secondary is what? 2 groups. Tertiary is 3 groups. That's by definition of primary, secondary, tertiary. But in another way to look at it, if you like, is think about each carbon has how many bonds? 4 bonds. If it is primary, means you have 1 group and a what? And an OH. So how many hydrogens on this primary? 2 hydrogens. Does it make sense? Primary means you have a group and you always have an OH. So this carbon will have how many hydrogen? 2 hydrogen. So what is primary? Primary is this carbon is a CH2. Again, which carbon? The carbon with the OH is attached to. So if you see a CH2, it will be a primary alcohol. If you see a CH, will be a what? Secondary alcohol. If you don't see any hydrogen at all, means what? Tertiary. There are 3 groups on it, plus O. That means there's a what? Tertiary alcohol. Does it make sense, guys? 2 ways to look at it, whichever you feel comfortable. By definition, we count the groups. But for me, it's easier. Just look at the hydrogens. Okay. However you get used to it. I just showing you 2 different ways of looking at it. Does it make sense, guys? Okay, I won't ask you. Tell me the definition of it. I'll give you molecule. We told earlier in the beginning, there are what? Limitless number of organic molecules. I just pick one anywhere to show you, hey, can you tell me what type of alcohol this is? Okay, let's try look at a few examples and then I'll show you some in-class tests. Okay, here, these are examples to see if you understand the assigned classifications. Primary, secondary, tertiary. Take a look, guys. I point the arrow at the carbon where you should look at. What's the carbon? The carbon is what? The carbon is the one that what? The O is bonded to. That's why you put your eyes on. Okay, you don't care the rest of the carbon. You don't worry about it. Can you guys tell me if you don't or cannot tell why they are primary, secondary, and tertiary? See, primary, 1 group on it, right? CH2. Secondary, 2 groups on it. CH. Tertiary, 3 groups on it. C, no H. Got it? Easy? All right. I'll call names. Sorry. Amanda? Can you tell me this guy? What type of alcohol? Okay, this is got a. This is a drug. Okay, this is it's called diflucan. It's the drug name is called fluconazole. It's used for fungus infection on your skin. Okay, very effective. So this is the structure of it. You will see that. If you have this drug and you open the manual, you will see the structure. Here, take a look. This is alcohol, right? See the OH? So what is it? What type of alcohol?
I don't know how to pronounce it.
Tertiary. Do you guys agree tertiary? Yes? Yes, it's a tertiary alcohol. This carbon has how many groups? 3 groups, and there's no hydrogen on this carbon. Okay, very good. It's a tertiary alcohol. Right, next. This is the structure, a very complex molecule. Okay, called taxol. Okay, called taxol. This molecule has been proven very effective on cancers. Okay, you can see the ovarian cancers, breast cancer, lung cancer, and pancreatic cancers. It's a natural product. It's isolated from the bark of that tree. Okay, so it's very expensive because the bark of the tree, once you peel it off, the tree is died. It's not like you can harvest leaves. Okay, so that's why this medicine used to be very expensive. Now the cost lowered a lot because we can do some semi-synthesize on it. Okay, it used to be extremely expensive, much more expensive than gold. Okay, so take a look. This medicine is, the reason is that it's called Taxol. Okay, that's a brand name, trade name Taxol. See that here's the name. It's because it has what? Have 3 OHs. It's an alcohol. So I've circled these 3 OHs. Jennifer, or no? Kristen, sorry. Can you tell me the classification of these 3? Okay, let's say left, middle, right. The left one.
Left should be
This one.
secondary.
Secondary. Do you guys agree?
I got to put second guess in myself.
No guess. You
I'm
can't guess.
second-guessing myself.
Secondary. Okay, this is a secondary alcohol. 2 groups. You see that? There's a hydrogen on it. Okay, there's a hydrogen on it. So this is a secondary. The middle one here. Tertiary. Okay, tertiary. Good. You don't have to pronounce. It's fine. I don't worry. This one on the right. Charlotte.
That'd be secondary.
Secondary? Do you guys agree secondary? Okay, it's secondary alcohol. Okay, this is the secondary and tertiary and secondary. Okay, guys, like I said, you don't have to pronounce. You don't have to tell me why, but you have to be able to tell. Okay, you have to be able to tell. And like I said, pick any molecules you see in this class and also in your homework and anywhere. Practice. Tell yourself why. You don't have to tell me in the test, but you have to tell yourself, and you'll be able to tell the test. Okay? Good. Next. Okay, next. Before we start the physical and chemical properties of alcohol, which are the main part of this chapter, I want to first show you a few alcohols. Okay, few alcohols that are extremely commonly seen and used. Okay, used not biological ones, but the ones that are actually used a lot. Okay, and produced a lot annually in industry and in commercial sectors. Okay, the first one is the simplest alcohol. Okay, simplest alcohol with only 1 carbon, methyl bounded to the OH. We call that methanol. Okay, methanol, which is by name is called methanol. Okay, methanol is one of the most important industrial solvent. Okay, we use a lot in our lab as well. You will use that too. Okay, it's one of the most important solvent. Okay, it's cheap. Okay, it's cheap. That's why we use it as a huge quantity as a solvent. Okay, it's effective. However, methanol is very highly toxic. Okay, highly toxic. The toxicity is mainly because you take it, take it by accident. Of course, nobody crazy enough to drink it. Okay, there are some countries, okay, those evil manufacturers use methanol instead of ethanol to produce alcoholic beverages. Okay, that cause, of course, death, and initial effect of methanol is blindness. Okay, it causes blindness, methanol. Okay, that's one, methanol. Number two is the one even more commonly to us, used daily by us, is 2-carbon alcohol called ethanol. Okay, ethanol. This is the alcohol. You guys call it alcohol all the time. That's the alcohol. Okay, you guys say I drink alcohol. This beverage contains alcohol. You're talking about this guy, ethanol. Okay, it is in beer, in wine, in liquor, in all alcoholic beverages. If you see a percentage of alcohol on the label, they're talking about the percent of this guy, ethanol. Okay, they're either produced by adding water to alkene. We studied this reaction in chapter 2, industrially, or most commonly is by fermentation using starch. Okay, starch. In the United States, the source of starch is corn. It's corn. Okay, why we do need this in a big amount? Not because we drink too much. Your cars runs on gasoline, but 10% of the gasoline is ethanol. You guys notice that? It says up to 10% of ethanol. We're burning that every day. I don't know who came up with the idea in the United States how many years ago in the Congress, why they do that. Okay. The problem is you're burning what? You're burning food. Okay. United States, the source of ethanol is corn. Okay, it's corn. It's not like you found something economical and more efficient. It's just silly. Okay, in Brazil, they use sugarcane to produce those. Brazil and United States are the biggest countries producing ethanol. Okay, to add in gasoline. The purpose, of course, is what? To reduce the consume of what? Of petroleum oil. Okay, that's the logic behind that. Why we burn it? It's less efficient than the gasoline itself. Okay, but you should know that there's no like a really good ways of making alcohol. We're basically converting corn into alcohol. Okay, into alcohol. And besides that, of course, there are industrial starting materials as well. Okay, and this is the picture showing you can do that fermentation at home. I know a lot of people do making their own wine, beer at home. Okay, a lot of people do that, and the fermentation process is the same as industry. It's just smaller scale. Okay, this shows you how you get an alcohol if you're interested. Okay, you can do it at home. It's fine. Okay, and this picture shows you the percent, okay, volume percent of ethanol in different kind of beverages. Okay, beverage. Even, I mean, sometimes you don't drink. Those other commercial products have alcohol as well. You don't have to drink to consume alcohol. For example, mouthwash, cough syrups, and flavorings like vanilla extract. They're extracted by alcohols. Okay. This is some chemistry of hangover. If you do drink, you can read to what causes it. What some people drink and their face turn red, and what's the reason behind it. Some people can drink more. Some people cannot tolerate that much. There's some chemistry behind it. Okay. Next is a 3-carbon alcohol. Okay, alcohol. Normally for 3-carbon alcohol, we call it propanol. However, this guy, the OH, is attached to the number 2 carbon of the 3-carbon chain. Do you guys see that? And we call this alcohol 2-propanol or isopropyl alcohol. Okay, isopropyl alcohol. Why we call isopropyl? Because this group is what we have seen already called isopropyl group. Okay, you can see, remember that Y-shaped group? Because isopropyl group. So commercial names on these bottles, they put it isopropyl alcohol, called IPA. Okay, you guys use this a lot because this is a very efficient antiseptic alcohol, cheaper than ethanol. Okay, and also as efficient as alcohol, as antiseptic, and also as astringent, like shrink your string and close your holes on your skin. Okay, you guys can buy those a lot. You can buy 70% of IPA, 90% of IPA, or 50% IPA. They're the same purpose. Okay, they have very similar odor to ethanol. Okay, next are two alcohols shown here. You can see that they're different than any ones we have seen so far. These alcohols contains what? Multiple OHs in their molecule. You can see that? This guy has 2 OHs in their molecule. This guy has 3 OHs in this molecule. Okay, they're called diols. Okay, diols mean the inner molecule has 2 OHs. Okay, don't worry, you don't have to name these molecules. Okay, the first one is called ethylene glycol, and the second one is called a propylene glycol. Okay, propylene glycol. They are very efficient antifreezes. Okay, antifreeze. That means they don't freeze when temperature is extremely low. Yes?
I'm just making sure. We don't need to study. We don't need to know those.
You do.
Oh,
you don't
do.
need, I just say you don't need to name those.
You don't need to name them.
Correct.
We recognize
Like
them.
when we name systematically, you don't need to name those.
Okay.
But you need to recognize what they
Okay.
are. Yes.
Okay. Thank you.
Yes. Okay. Antifreezes are not just used for example, de-icing airplane. You guys, your cars have antifreezes too. Okay, some of you have worked on that, some of you not. Your car engine has antifreeze, so that your engine doesn't go. The water, you know, your cars is cooled by circulating water. Okay, but water, the freezing point is around 0 degrees Celsius. They will freeze during winter. So you add these, especially this guy, ethylene glycol, normally 50%, 50%, to prevent freezing of your circulating coolant of your car engine. Okay, car engine. If you buy it from AutoZone, for example, there could be pure ethylene glycol or 50%, 50% water mixed. Okay, the last one shown here is a triol, meaning in the molecule there's what? 3 OHs. Okay, 3 carbon, 3 OHs. The name of this molecule is called glycerol. Okay, glycerol. Sometimes people call it glycerine. Okay, this molecule is very important. Okay, we'll see this guy again in chapter 8 because that's one of the component of our body fat and oil. Okay, we have a lot of these in the body to synthesize our body fat and oil. Or when you eat some fried food, for example, okay, the lipid of this fried food will be digested into fatty acid and glycerol. It's one of the important components of body fat. And this guy itself, okay, glycerol, is a very, very nice, non-toxic, and highly effective moisturizing agent. What does it mean? It will keep moisture. You can put it on your skin if you're winter, like my hands are extremely dry. Putting glycerol on your hand will keep it moisture for a very good long time. The only thing is it doesn't smell that good. So because of that effect, it is actually used in all cosmetics. You girls use creams, night creams, day creams, whatever creams you use has this glycerol to keep moisture. Okay, glycerol. Because it's non-toxic. We have those in our body a lot. All right, so these are some things to show you the alcohol since we're learning them. Okay, learning them. Just examples to show you. All right, next, the physical properties of alcohols. Okay, physical property in alcohols. Alcohols are no longer like hydrocarbons because of this particular group, the OH. Okay, the OH. OH is a polar group. Okay, it's a polar group. Polar means when you have an oxygen with hydrogen bonded. Okay, hydrogen bonded. Oxygen, this guy, likes electrons more. So when these two guys make a bond sharing electrons, the oxygen will pull the electrons more towards itself. So this part of the oxygen or the molecule will have more negative charge. The hydrogen will have more positive charge. That's why we call this group polar. the charge distribution is not even. This guy is more negative, you can mark it, some negative. This guy is more positive. And because of that, the OH of an alcohol can interact with water. Remember what is water? Water is what? A lot of OHs, right? OH, OH bond. And which is the same. Water has OH too, so that means what? The O of water will have what charge?
Which?
What charge of?
Negative.
Negative charge. The H of water will have what?
Positive.
Positive charge. Take a look, what are they doing? The positive of the H from the alcohol interact with what? The negative of what? Of water. Do you guys see that? The negative of alcohol interact with the what? The positive water. O interact with the H. O interact with H. And that dashed bond interaction, we give it a name called hydrogen bonding. Hydrogen bonding. And showing over there as well. Okay, showing over there as well. Hydrogen bond. Why we call hydrogen bond? Because they interact through what? Via hydrogen. Again, the interaction is no mysterious type of interaction. It's basically what? Negative, we interact with what? Positive. Positive interact with what? With negative. Because these OHs are what? Polar. Okay, they're polar. And because of the interactions, these hydrogen bonding interactions, a lot of them, these only shows, think about, this only shows one alcohol as two water. You have a lot of molecules, they're actually interacting with each other a lot. And because of that, alcohols tend to be water soluble. Okay, very water soluble. Very water soluble. That's first physical property, very important. Alcohols, because of the OH, that is polar, can interact with water through what? Hydrogen bonding. So alcohols are water soluble. Next. Okay, next. The reason alcohols are water soluble is again because of what? The OH, the functional group. But alcohol doesn't just have OH. Alcohol has the other part, the R group, the carbons. Okay, the carbons. So the size of the group will also affect the solubility. When the size of the group is small, like this guy, one carbon group. So this molecule is what? It's tiny. So in this case, the OH is dominant. So this molecule is very what?
Soluble.
Soluble. But if you take a look at this guy, still alcohol, right? OH. But take a look at this group. It's huge. And this group not only is huge, we know this chain, take a look, without this chain, this is a chain of what? Hydrocarbons. Is that right, guys? We know hydrocarbons in chapter 1 are the what? Not soluble. Is that right? So when the molecule is big, when the R group is big, what happened is the OH won't be that dominant anymore. Which is more dominant? The tail. The big part, the carbon chain, will be more dominant. And when this is more dominant, what happened? The molecule will more look like what? The chain instead of what? Alcohol. So, what would you expect? That molecule will what? Not dissolve in water. Does it make sense? Okay, when the chain gets bigger, the OH never gets bigger. When the chain gets bigger, the molecule will more and more look like what? The chain. Okay, and that chain we know is from chapter 1 is what? Is a hydrocarbon chain. It doesn't dissolve in water. Okay, it doesn't dissolve in water. So because of that, it's a very important trait. You can see that. This chart shows you the solubility of alcohols ranging from carbon number 1 to carbon number 7. When you have only 1, 2, and 3 carbons, you can see that they're completely what? Soluble. That means you can mix them with water no matter how much you want. Because they're what? They're small. The OH dominates. But when you increase the carbon number to 4, you can see that the water solubility dropped to where? To around 8 grams per 100 mils of water. When you further increase the carbon number to 5, the water solubility further drops to what? 2 point something now. And if you further increase to 6 and 7, you can see that close to 7, the water solubility dropped to where? 0. Tells you what? Tells you when you drop to 7, the solubility of the alcohol is close to what? To the tail now, to the hydrocarbon. Good? So far, what did we learn? Alcohols, because of the OH, they can interact with water through what? Hydrogen bonding. And because of that, alcohols are generally water soluble. However, there's a trend, there's a condition. That means the chain of the alcohol cannot be too big. Because as you increase the number of carbons for alcohol, the water solubility is going to what? Decrease. That's all you need to summarize. Like I said, I won't ask you to summarize. You have to be able to summarize and know these facts. Does it make sense, guys? Everything for water solubility, why they're soluble, and why the solubility decreases. Please know the trend. Okay. Know the trend.
Can you say the summary again? Like
First, alcohols because of the OH,
Okay.
which is polar. Then alcohols will interact with water molecules through hydrogen bonding. And because they can interact with water, so alcohols tend to be water soluble. However, if you increase the size of the molecule, basically increase the R, the chain of the molecule, the water solubility is going to what? Decrease. Okay, decrease.
Thank you.
The reason is what? The reason is as you increase the chain becomes more and more what? Dominant. Does it make sense, guys? Okay, that's first physical property about water solubility. Next. Okay, next. If you understand the hydrogen bonding of OH, of alcohol with water, you will have no problem understanding the OH of the alcohols can interact with themselves. Okay, this picture shows you 3 alcohols of the same, they're the same molecules. You can see that the O of one alcohol interact with what? The H of another alcohol. The H of one alcohol interact with the O of what? Of an alcohol. And this guy can interact with another alcohol. The thing, we call that what? Hydrogen bonding. Right? Right, because the OH is what? It's polar. This is negative charge, that's positive charge, that's positive charge, that's negative charge. So alcohols themselves, without water, are still interacting through hydrogen bonding. And because the molecules are interacting with each other, because they are 3 molecules, it's harder for them to what? To separate. Harder for them to separate means what? If you want to change them from liquid to gas, you're gonna need what? Higher temperature. Does it make sense, guys? You need higher energy to separate the molecule because they're what? They're bonding to each other, hydrogen bonding. So that means alcohols have much higher boiling points than hydrocarbons. Does it make sense? Remember hydrocarbon in chapter 1 we said they are generally low boiling point. Why? Because the molecules are not interacting with each other. Okay, the interaction between hydrocarbons is very weak, so they're very easy to separate apart. Alcohols are different. The interaction between these molecules are what? Are strong. So their boiling point is what? High. Boiling point high means what? You need a higher temperature to boil them, to change them to gas, to separate the molecules.
So in this property, the length of the carbon chain does not make a difference, correct?
It does. Okay, we'll see that right away. Here is the chart showing you the, sorry. the boiling points. Alcohols, they have much higher boiling point than what? Take a look. The hydrocarbons. But alcohols themselves, the boiling point also increases as what?
The length of the
The chain increases. Okay, the size of the molecule increases, which is the same trend as we learned in chapter 1. You guys remember that? The boiling point of hydrocarbons increases as what? As the number of carbon increases. Is that right, guys? Well, you see the same trend as alcohol. Okay, same trend as alcohol. But if you want to compare across the species, alcohol has what? Much higher than hydrocarbons. So that means, starting from here, if you want to compare across species, if you want to compare an alcohol with a hydrocarbon, you should compare them what? In similar size. Does it make sense? You don't compare like 1 carbon alcohol to 10 carbon hydrocarbons. It's not fair. There's no one would compare it like that. Does it make sense? We say alcohol has much higher boiling point than hydrocarbons. We're talking about what? Molecules of what?
Same size.
Similar size. Then we compare them. Okay, we find out alcohol is much higher. Because of what? Because of this guy has what? OH. This guy doesn't. Does it make sense, guys? Okay, we'll see that too. When I give you molecules to compare, if there are different types of molecules, they should be in different sizes. Okay, you assume they're different. When I give you, I won't ask you the size are different. They will be similar in sizes. Does it make sense, guys? What we're talking about here? That's all the physical properties. And again, I hope you all can summarize, itemized what we learned about these. Okay, water solubility, what is this trend? And boiling point, what is the trend? And how do you compare the boiling point of alcohols with what? With hydrocarbons. We only learned 2 types of molecules so far, alcohols and hydrocarbons. You good? You guys, any questions about physical properties? Alcohol? Good? All right. Let's move on. The reactions of alcohols. Okay, the reaction of alcohols. We only learned 2 reactions of alcohols. Okay, 2 types of reactions. The first reaction is called dehydration. Okay, dehydration reaction. Dehydration, the word you're not unfamiliar with, right? What is dehydration?
removal of water.
Taking water, right? You remove water. Okay, remove water. And because of that, this reaction is also called an elimination reaction. Eliminate what? Water. Okay, eliminate water. So here is the scheme of the reaction. Again, I'm not using full molecule, just part of it. The part you are focusing on. Here, take a look. Is it what? Alcohol. Is that right?
Right.
OH bonds to a
Carbon.
carbon as an alcohol. So what happens is here is if you remove the OH and then you remove the H of the adjacent carbon, so you can see that H and OH, again, we're taking away what? Water. What is water? H and OH. OH apparently from what? From the alcohol carbon. H from what? The adjacent carbon, the carbon next to it. So you're taking what? H and OH from 2 carbons that are directly bound together. These 2 parts become what? Water. But if you take these parts, then you have to deal with these 2 things that are empty. Then what?
Double.
They make a double bond. So dehydration of an alcohol gives you a what? Alkene. You guys see that? An alkene. The reaction condition for dehydration is shown here at 180 degrees Celsius. That's normally the temperature we use. And also use concentrated sulfuric acid. Okay, concentrated sulfuric acid. Okay, concentrated sulfuric acid itself will serve as a dehydrating agent as well, because they want to take water away. Okay, they want to take water away. Okay, we will use concentrated sulfuric acid in our lab as well. Okay, if you by accident drop on your skin, wash with water a lot. If by accident drops on your lab manual, you will see a big hole and turn it black and brown. The reason is the water is sucked away. Okay, like I said, concentrated sulfuric acid is a dehydrating agent. Okay, we only use drops. We don't use a lot. So that's where I will ask you, hey, you guys better put on gloves. You guys understand the reaction? Dehydration, remove what? Water. Water is removed as what? OH and what? H. OH is apparently from this carbon, where the OH is attached. But H is not from the same carbon, from what? The carbon neighboring it, the adjacent carbon. Is that right? Then you need what? Make a double bond. Okay, make a double bond. Right? Okay, this is the reaction. Then let's take a look at a real example. Tell me if you understand. Right? OH is where? Here. Remove the OH, remove the H. Again, like I said, when we do reaction, what would you do? Copy to the right, right? Then you use your eraser what? Take this away and put 2 dots here first, so you know I'm looking at these 2 carbons. And then you erase these 2 and then what? Make a double bond. You're super easy, is that right? But you first copy, so you don't miss anything else. Okay, and also pay attention to the condition. How would I know? How would I know, hey, I want to do dehydration? Sometimes I don't put a word dehydration here. How would you know? You take a look at this. 180 degree. Okay, you don't need to exactly memorize 180. If you could, it's better. You know you need a what? High temperature. High temperature. And sulfuric acid. Okay, concentrated sulfuric acid. And you get alkenes. Okay, you get an alkene. Next. Okay, next. I know some of you already have this thoughts or want to ask this already. Is when dehydration happens, okay, when dehydration happens, there's a possibility that the neighboring hydrogen are from 2 carbons. For example, let's say in this case, if you take a look at this molecule, the OH is here. It's called 2-butanol, 4 carbons, right? This is where the OH is attached to. So if you want to take water away, OH is from here, no problem. But the H can either be from number 1 carbon, this is 2, right? Or what?
3.
Number 3 carbon, because there are 2 carbons next to the number 2 carbon. Either 1 and 2 or what?
3.
2 and 3, because both of these 2 carbons have what? Have hydrogen on it. So that means you can remove water between here and here, or what? Here and here. Do you guys see that? If water is removed from here and here, 1 and 2, then your double bond is between what?
1 and 2.
1 and 2. If your water is removed from 2 and 3, then your double bond between what? 2 and 3. You end up with 2 molecules. Do you guys see that? Okay, that's a possibility. Okay, for this class, I won't ask you which one is major, which one is minor. You don't care. If it is reaction, you only need to give me 1. Does it make sense? If in multiple choice, you only see 1. Does it make sense? Is that easy? It makes it very easy for you. You only need to figure out the reaction. If I say, I didn't see this hydrogen, fine. As long as you see 1 hydrogen, you give me the product, I'm happy. If I really wanted to test you, I may give you the other one. Hey, can you tell me the other one as a bonus points? I can do that. Does it make sense, guys? Right? You don't have to worry about which one I choose. There's a preference, in fact, but you don't have to figure out for the scope of this class. Does it make sense? But first understand why we have 2 products. Both are products. Between 1 and 2 or what?
2 and 3.
2 and 3. The reason is there are 2 what? Adjacent carbons to what? To the OH carbon. Good? Make sense, guys? Do we need to work on the reaction? Okay, let's try work 1. right. This is the alcohol. This is the dehydration condition. And you guys work on your scratch paper and show me a product. Okay, you don't have to show me all possible products. Just show me one based on what we learned for dehydration. Show me a dehydration product. Very good. Beautiful. Copy and then think. Did you copy? What is this? Just follow. He said, you may have your own method, but I strongly encourage you to do it. Where's the double one? Remember, they're getting alkenes, right? Where's the double one? And did you copy the structure? You didn't copy the structure first. That's not what you get after you copy the structure. Okay, think about it. That's good. Okay, first, guys, copy, then work on the water is gone. What is the word that you copy? Water is not shooting water. Water is like taking away as a product, but not on the molecule. Right? Think about it. Good. But something is missing because you didn't copy the structure first. There we go. If you copy, you won't miss that. That's what I meant. You probably know how to do it, but if you don't copy, you're losing something. The structure is wrong. All right, guys, let's work together. Okay, guys, please. I know you will get ear tired, but please, always what? Copy the structure first. Whatever you saw, draw on the right. Okay, draw on the right. Then work based on what we studied on dehydration. With that, dehydration is taking what? Water, right? Taking water from how many carbons? 2 carbons. So you need to mark it. One of the carbon is here because this carbon bonds to what? To the O. Is that right? Then you need to ask which are the neighboring carbons, right? One carbon neighboring is here, another one is neighboring here or here. I just say you don't care as long as you find one carbon that's neighboring what? That carbon, you're good. Okay, you don't have to give me multiple parts, as long as one. So I found this carbon is neighboring what? That carbon. So I put 2 dots here. I know these are the 2 carbons I'm looking at. Good? Then what do we do? Dehydration means what? Take away the OH and take away what? The H. Does this guy have an H? Yes, this guy has how many H? 2. So I assume, hey, I take an H away. Then I do what? Make a double bond. Done. Easy? Okay, I know in the beginning it sounds crazy, but I hope you start to click what it means. Okay, some of the methods I show you may seem silly, but it will be helpful, guys. Okay, you put the dots here, so your eyes are only on here. Nothing else is changing. You don't care. Does it make sense? Okay, find the OH carbon, and then find the double bond, the other carbon, neighboring carbon. Then what? take the OH, take the H. There was an H, there was two H here, so there's just definitely one for you to take away. You don't care, just pretend you take away. Then what? Then make double bond. Then just take the white, the dots you draw. This is the product. Okay, this is product. Or you can put the product here. These are all other products. Okay, you can put the double bond here. Or you can put the double bond here. Between these two. You can do that too. They're all products, but that's the one I want to see the most. Does it make sense, guys? Okay, we'll practice more hopefully next week during our recitation. But again, guys, I hope you to understand first what this reaction is about. Then be able to work on the structure, but please copy first. Okay, copy first. Next. Okay, next. The dehydration reaction. Okay, the dehydration reaction is actually the reverse reaction
Hydration.
of hydration. We learned in chapter 2, if you guys remember. Right? What is dehydration? Take H and OH to make a what? Double bond. And then remember in chapter 2, we're going to do the quiz. You will see this in your quiz. Is if we want to add water to the double bond, what do we do first? Take the double bond, add H and what? And OH. Do you guys see that? They're actually reverse process, we should say that. But the experimental conditions are different. For hydration, we don't use concentrated sulfuric acid, we use diluted one. But for dehydration, I use what? High temperature and what? Concentrated sulfuric acid. Experimentally, they're different. But they're actually reverse process if you understand these two reactions. Does it make sense? Okay, again, hydration is what? Take the double bond, add what? H and what? OH. Here, reverse is what? We take away H and OH, then what? Make the double. You can see even our workflow is what? Reversed. Okay, that's why you make some summary. As you learn, you will get, again, hopefully you click as soon as possible. I know it takes some time to click, but practice, only practice make you better. Trust me. Practice make you better. You watch the video again, do the same question we did again. If you're still not able to do a homework question correctly, watch the video again. Do the practice again. There are plenty of them in this lecture already. You don't have to find extra sources to practice. These are the ones I ask you. These are the method I hope you to use. Okay, good. That's the first reaction, dehydration. The second reaction, okay, the second reaction is oxidation. Okay, oxidation. In oxidation, of alcohol, what we did here, or what we're doing here, is we remove two hydrogens from the alcohol. Those two hydrogens are from C and O. You guys see that? We know hydrogen, OH has a what? Has a hydrogen, right? That's hydroxy group. That's the alcohol. Then I remove a hydrogen from the C as well. C and O. So I take two hydrogens away. Then after I take these two hydrogens away, I what? I put a double bond. Now it's a CO double bond. Why CO? Because I'm taking hydrogen from C and what? From the O. So I need to make a CO double bond. And we call this process oxidation. And here brings a very simple definition of oxidation. What is oxidation in organic chemistry? And oxidation in organic chemistry means increase CO bond or decrease CH bond. You can see that? We decrease what? CH bond, because we take hydrogen away. Then we do what? We increase what? CO bond. Normally, previously it was CO single bond. Now it's CO what? Double bond. That's what we call the oxidation. That's a definition, universal definition for organic chemistry. if you increase CO bond and or decrease CH bond, we call that process oxidation. There's a reverse process. If you increase CH, decrease CO, we call that reduction. Okay, there's a reverse process. But here, oxidation means decrease CH, increase what? CO. Does it make sense, guys?
One hydrogen is removed from oxygen and the other hydrogen will always be removed from the adjacent carbon?
From this carbon adjacent to the O.
Okay.
Yes. Yes. Because they're bonded together.
Okay.
Right? And oxidation needs some oxidizing agent. These are the commonly used one. And you don't have to memorize any of them. If I ask you to, or if I hope you can do an oxidation, usually I will put a sign like this. A big O in a parenthesis or a bracket. That means, hey guys, this reaction is oxidation. Does it make sense? You don't have to show any of those. Okay, you don't memorize. But these are the commonly used oxidizing agent. Okay, oxidizing. All right, this is part of the general reaction. Let's take a look. Two specific cases. The first case is a primary alcohol. What is a primary, you guys still remember?
Carbon is
This
attached.
carbon to where the O is attached to has how many groups?
One.
One. And because there's one group, this carbon has how many hydrogen on it? Two. Right? That's primary. Why we care about the hydrogen, guys? Because we know in oxidation we're gonna what? Take one away. Is that right? So take a look. I take the OH from the O, take the H from the C, make a what?
Double bond.
CO double bond. Is that right? You guys see that? And we know this carbon had what? Two hydrogens. Now only has what? Has one. You can see that? And we call this molecule with CO double bond and a hydrogen on the C. We call this molecule an aldehyde. Okay, an aldehyde. We'll study that in chapter 4. Remember we said chapter 4 we talk about CO double bond. This is one of the molecules we studied in chapter 4, an aldehyde. Why is an aldehyde? Because what? Because of this H. Why there's an H? Because they had two H, you only took one away. Does it make sense, guys? Okay, that's an aldehyde. Okay, aldehyde. Aldehyde will be further oxidized into carboxylic acid, which we will study in chapter 4 as well. Okay, but the reaction is here already. Okay, you won't see that in your quiz for this further one, but we will eventually study it. So if you were interested, you can take a look now. That's primary alcohol. The bottom one is an example of primary alcohol. You can see that this is ethanol. Take the H from the O, take the H from the C, what you get?
Double
CH3, CO double bond, and what?
One.
An H. Do you guys see that? Between the C and O, you make a what? Double bond. Is that right? But you have to take the OH away, take what?
H.
One of the H away from here. That's why the CH2 now becomes what? CH. You can see that? Two carbons, total two carbons. But the reaction happening between C and O. Make sense? Okay, this is an aldehyde. Okay, aldehyde. Of course, aldehyde will be further oxidizing to carboxylic acid.
Acetic.
Okay, this is the reaction actually in hangover. You guys straight alcohol, this is what happens alcohol in your liver. Your liver does this reaction after you drink wine, beer, liquor. Does it a lot, depends on how much you drink. This is the product actually get rid of your system. And this product is toxic. That's why if your liver accumulates to this well will have damaging on your liver. That's why heavy drinking is not recommended because of potential damage of liver cells because of this product, the intermediate product. Right? That's primary alcohol. Let's take a look at the secondary alcohol. Why secondary? Because on the carbon there are what? Two groups. And because of two groups, there's only one hydrogen what? On this carbon. Is that right? Still, oxidation is the same. Take what? H from the O, H from what? The C, and then what?
Double bond.
Make a double bond. Now this carbon, there's no hydrogen on it anymore. We call this a ketone. Okay, a ketone. A ketone is very stable, won't go further oxidation. Okay, we call this a ketone. And the bottom one is an example of ketone, of the secondary alcohol being oxidized. Do you guys understand the bottom reaction? Remove the H. Remove the H. Then what?
Double bond.
Make a double bond. Is that right? See that? Double bond. Okay, next. Okay, you guys expected already. If we have a tertiary in alcohol, what is tertiary? 3 groups. That means what? This carbon has what?
No hydrogen.
No hydrogen. But oxidation, we need to remove a hydrogen. That means what? Tertiary in alcohol will not be oxidized. Does it make sense? And you do the same thing. If I give you a tertiary in alcohol with that, you write what? No reaction. Because that doesn't mean, oh, I won't ask you. I will. You have to tell me if there's a reaction. If no reaction, you put no reaction. Tertiary in alcohol will not be oxidized. The reason again is what? There's no hydrogen on this what?
Carbon.
On this carbon. You cannot make a double bond here. Remember, there's 4 bonds already. If you make a double bond, it will be 5 bonds. That's not possible. Is that right? Yes? Alright. Here are the summary of the alcohol reactions. Okay, the summaries of all the alcohol reactions. Dehydration, oxidation. Oxidation, of course, can either be from primary or what? Or secondary. I labeled the one hydrogen you remove in blue, okay, to help you further visualize this process. And then tertiary in alcohol cannot be oxidized. Okay, these are the reactions for alcohol. I think the class time is over. We'll practice more of these reactions in our recitation next Wednesday. Okay, can you stop the recording, please?
Oh.